Okay, so it's exactly 1:30. Yeah. Okay. So hello everyone. So we really appreciate you taking time off your busy schedules to join us today. Hence, first and foremost, thank you for attending today's session. And on behalf of Shimazu Philippines Corporation, we would like to warmly welcome you to this live webinar on Spectrophotometer for Life Science Applications BioSpec-nano. I am Laika and I will be your host for this afternoon. So before we start, let me just discuss some webinar rules. Firstly, today's webinar is being recorded, so we will be uploading this to our YouTube channel. Secondly, all the attendees except for the host and speakers are required to mute their microphones and turn off their video all throughout this session. And lastly, you may utilize the Zoom group chat box that you are seeing in your screen to type in your concerns and questions, so especially during the live Q&A later and the presentation as well. So here is the program outline for this webinar. We'll start straightforwardly with a presentation, followed by a short demonstration of the basic operations of BioSpec-nano, brought to you by our regional office in Singapore. So we have invited our colleagues from Shimazu Asia Pacific Singapore. And finally, there will be a Q&A in the end to address your queries. So if ever you have questions during the presentation, just feel free to type it in the chat box. And at the end of this session, actually, we prepared something for you. So be sure to stay with us until the end. So moreover, we will be giving out e-certificates. So after this live webinar, I will be sending you the link where you can accomplish the feedback form. So that is via Google Form. That will actually also serve as your attendance. Now, so moving to the highlight of this webinar, the presentation proper as well as the demonstration. So it is my great pleasure to introduce to you our guest speaker, who is from our regional office in Singapore, so the Shimazu Asia Pacific. And she is none other than Nicole Zhang. So Nicole is the Senior Product Specialist of Shimazu Asia Pacific in Singapore. Prior to joining Shimazu, she worked in different companies in the analytical instrument industry for more than 10 years, from chemist marketing and in charge of different technologies from LC, MS to Spectro products. Since the year of 2018, Nicole has been responsible in providing marketing and technical support to Asia Pacific region, including Philippines, when it comes to LCMS and spectroscopy instruments. So without further ado, let's welcome Nicole. Nicole, please.
Thank you, Laika. Hello, good afternoon, everyone. It's really my pleasure to be here to share with you on the Shimazu spectral products, especially Shimazu BioSpec-nano. So which you can see is really very unique in terms of the technology, in terms of the product itself. Let me quickly share my screen now so that you can all see the slides. I hope you will enjoy the session by the end of today as well. Okay, let me just quickly check on this. All right, without further ado, I'll start. Good afternoon, ladies and gentlemen. Thank you for spending time this afternoon with Shimazu. My name is Nicole. I'm from Shimazu Asia Pacific, based in Singapore. Today, our topic will be Shimazu Spectrophotometer, which we are specifically focusing on one model, which we call it BioSpec-nano. Before we go into the topics today, I just want to quickly share with you, Shimazu has been in the market in the analytical industry for more than 146 years. We established back to 1875 in Japan, Kyoto. Of course, our company philosophy is continuously contribute to society through the science and technology. Shimazu is the only analytical instrument companies with such a long history, and in addition to that, Shimazu is also the only analytical instrument companies who also provides the medical instruments as well. So along the many years of the history, Shimazu has been achieved many milestones. So the most related to analytical instruments, which will be Shimazu at the year of 1952, developed Japan's very first spectrophotometer instruments, and also currently Shimazu is the only analytical instrument company who awarded as a Nobel Prize in Chemistry back to 2002 by our multi-top technology. So you know Shimazu has been in the market for so many years. Therefore, we provide many different kinds of technology. So if you can see analytical instruments, which which includes from spectrophotometer, UV visible instruments to FTIR to chromatography, mass spectrometry, and multi-top. And in addition to that, Shimazu also provides scientific testing and different types of the balance instruments as well. As we mentioned earlier, Shimazu is the only analytical instrument companies who also provides the medical systems as well. So you can see we have different types of the X-ray systems, and also these all are designed for medical use or for medical purpose. Shimazu Asia Pacific Corporation were established at year of 1989 in Singapore. So we are the regional headquarter for the whole Asia Pacific, which includes from India, South Asia to ASEAN region. And we are not only just the sales and the marketing offices in Singapore here, we also provide the application development and support, technical support, which is our service team, as well as we also have regional research and development facilities as well. So we develop softwares, we develop certain programs, which is specifically to help customers to further enhance their instrument hardware in addition to what they are getting from the hardware as well as the software. So this is our office in Singapore. We hope after the pandemic is over, so you can come to the office to just take a look of our support center, our research and development center as well. So first, what is spectrophotometer, or what is the spectroscopy, and what is the technology and what it can do for us? So spectroscopy technology, it is small in terms of the hardware designs compared to most of the analytical instrument company or most of the analytical instruments in the market. It is easy to operate instruments. So spectroscopy, usually we are referring to UV visible instruments, the FTIR instruments, and of course, in terms of the analysis time, usually for all the spectroscopy instruments, you just need to get the results within a few seconds. So unlike any of the chromatography system or even chromatography mass spectrometry systems, usually you need the analysis, the runtime minimum maybe 10-12 minutes. For any of the spectroscopy, spectrophotometers, you just need to place your sample, and usually within 20 seconds, you will straight away can get your results. And there is another good thing for spectroscopy technology, which requires a minimum sample preparation. Of course, for UV visible instruments, for example, spectrophotometers, sometimes you need to have a liquid sample or cream or even a solid samples, a powder. But again, when you're comparing with the chromatography instruments, which you have to go through a theory or a process of the sophisticated or complicated sample preparation procedure in order to get the sensitive results. So spectroscopy, the sample preparation is much easier. And sometimes it can be even without any of the sample preparation. So for example, a lot of customers are using the FTIR for film analysis, which you don't even have to, or even for packaging material, for food packaging. So you don't even have to go through any of the sample preparation. You just need to place directly of your packaging material at certain thickness under the FTIR instruments, and then straight away you can get your results. For example, the combination of the packaging material sometimes can be even the thickness of the material. And because the instrument itself is very simply designed, it's using a lot of light reflections. So sometimes it will be requiring a lot of different types of the accessories, attachments for different analysis, different applications. So it can be very flexible and it can be complicated sometimes as well. And usually for any of the spectroscopy instruments, unlike the chromatography, the mass spectrometry, you need to maintain the laboratory condition, you need to maintain the temperature, you need to maintain the humidities. Of course, for spectroscopy, especially the FTIR, you need to maintain a certain humidities for the laboratory conditions. That is because of the any of interferometers are very sensitive to the humidity. Rather than that, for any of the UV visible instruments, really you don't really have to have very stringent laboratory conditions while you still can run the system easily. So if it's such a simple technology, it has been in the market for more than 60 years, then of course, what is the applications? So spectroscopy technology, it can still be used for identifying of certain unknown materials, certain unknown compounds of interest, but definitely it is not as sensitive as the chromatography mass spectrometry. You can determine the quality of the sample, but especially when you have the concentration of your sample at a high level, not at ppb or sub ppb level, okay? That is out of the scope of any of the spectroscopy instruments. Of course, you can do a quantitative analysis as well for certain compounds of interest in your sample. So it's still, even though spectroscopy has been in the market for so many numbers of years, but it's still a very useful technology, especially when you have a high concentration compounds, for example, for any of the pharmaceutical, the API analysis, which still 95% of your any of your pharmaceutical samples can still be very, very helpful. So this is a very simple structure of the spectroscopy, or you can call it a UV visible instrumentations. So you have a light source which generates the lights, either a visible light or the UV, the ultraviolet light range. Then you have a monochromator which will help you to split the lights in based on the different wavelengths. And then the lights selected, the light range will be inside onto your sample compartment, and those non-absorbed light will be traveled to the detector, and then the detector will convert the data into a spectrum, and that is you will have your spectrum information. So what is can be used? So as we mentioned earlier, spectroscopy instruments or spectrophotometer instruments can be applied to identify simple unknown compound of interest. And there is another wide applications which is using for quantitative analysis. So what is the quantitative analysis? There are three steps basically. The first step, you need to have your standards at the different concentration level, and based on the different concentration levels and the response in terms of the absorbance value, you can draw a calibration line. Okay, so from the known concentration and based on the absorbance value, the calibration curve will be able to draw. Okay, and then next with your unknown samples, which you want to find out the compound of interest, what is the concentration. So what you have to do is, based on the absorbance value and based on the calibration curve, you will be able to join, or you will be able to calculate back what is the potential concentration of your sample. So this is about the quantitative analysis. So from any of the unknown samples absorbance value, You draw the line based on a calibration curve, while you can calculate back what is the potential compound of interest concentration. And it's usually we are looking at ppm, parts per million level, for any of the spectrophotometer instruments. So for BioSpec-nano, what it can do for you. So this is how the BioSpec-nano look like. It has been controlled by a laptop, but from the size of a laptop, you can see it is a very, very small in terms of the size of the instruments. So this is a very specific instrument, very specific UV visible instruments. It is a very simple to use instrument. It focuses on highly accurate quantitative analysis of any nucleic acids and proteins with a quicker and faster workflows. And this is to be analyzed by photometric measurement is possible. And it has a very unique features because it can do a sample with only 1 to 2 microliters of a sample. After you place your sample onto the sample plate, it will be mounted automatically and it will be wiping out, that means clean automatically as well. So let's take a look at the very quick features. So number one, nucleic acid quantitative analysis, which usually you will have a very limited sample in size. So for any of the BioSpec-nano analysis, we only require 1 to 2 microliter of the sample. And you have two options of the path length, either it's 0.2 if you have 1 microliter or 0.7 if you have 2 microliters. And it's an easy drop and start measurement. Drop, that means you just need to drop your sample onto the sample plate or the sample mounting, and then you can just press the button of the start. It will automatically do the analysis for you. And it is very quick, very simple. You will be expecting your results within a few seconds, and it's really a stress-free analysis with the data judgment functions as well. So combining all these features, the workflow point of view, there are only 4 steps. As we mentioned earlier, based on the sample volumes you're choosing, you're applying 1 or 2 microliter, and the instrument will help you to choose the path length based on the sample volume. So what you do is you just drop your sample at dedicated sample mounting, and the instrument will automatically choose the optical path length and will do automatically cleaning for you. The most importantly, a lot of you may having these questions. So if you do automatically cleaning, how the cleaning will be, how the quality of the cleaning by the automatic workflow. Because we did, of course, analysis as well, there is a very, very low amount of the carryover can be achieved with the automatic wiping function. And the next step after is choose automatically, and if you be doing the start the analysis by just click the button of the start, and then within a second it will display the real-time measurement of the results. And of course all your results can be saved as well, either in a PDF format if you already preload your sample results format, or it can even be saved in a CSV format, which allows you to do a further analysis. Last step, you have to check your analysis results, because we believe whatever we include is always whatever the result is always the most important to the customer. Whether it's a good quality result or the result has to be repeated, the whole analysis should be restarted. All these are considered. You have to check your results. So how the results look like. So we did a quick analysis as well. When you have the 1 microliter of your sample for the analysis, the path length as 0.2 millimeters. We did 10 continuously measurements with the CV of less than 0.84%, which is extremely good. And of course, we repeat the same things for 0.7 millimeter, that means 2 microliter of your samples. And both actually was done on the double strand DNA. So the CV was 1.4%. So you can see, be it 1 microliter or 2 microliter of a sample, your reproducibility for turn continuously measurement of the samples are excellent. And then, of course, the instrument is not only designed for the DNA, it can be applied for the BSA, for the protein as well. Again, we repeat the same sample, we repeat the same experiments, 10 successive measurements for 3 or 4 microliter of the proteins. CV at 1.05% and the 0.98% were achieved respectively. So you can see the instrument is very accurate in terms of the very low variations. And all these are very important, especially when you want to do a quantitative analysis. Okay, so we have a lot of the different types of the application notes for you to choose from. We have application notes for quantitative analysis for nucleic acid, for modified food, as well as since the COVID-19 has been the pandemic since last year. So BioSpec-nano was in high demand, especially before the RT-PCR was started. So usually a lot of the testing labs using the BioSpec-nano to do a quick analysis on the sample itself to see whether there is enough or sufficient amount of the samples. So all this can be applied by the BioSpec-nano technology. So a quick summary here. BioSpec-nano was designed for simple, easy analysis for life science applications. It provides a very accurate and reliable, repeatable quantitative results with just within 1 to 2 microliter of your sample. And again, it was designed specifically for nucleic acid as well as for protein analysis. So of course, Shimazu will have, it's not only having a BioSpec-nano, we have a wide range of the spectrophotometers as well. We have UV1780 model, which was from China, and we have the rest of the models which from Japan. So for example, we have the UV1280, which is specifically designed for water analysis. We have UV1900i, which is our flagship model, which is fully compliant with pharmacopoeia regulation requirements. And we have UV26-2700i, which are designed for not only the liquid analysis, but also the powder, the cream, the film analysis. And again, we have more sophisticated more advanced UV3600 and 3700Is for advanced material research analysis, also for construction analysis as well. So with all this, I end my presentation here. And now I'll pass the time to my colleague Jen Hao, will be doing a real-time analysis for you. So you will really experience how the BioSpec-nano works. And after that, we'll be having a Q&A session.
All right, so thank you, Nicole, for the presentation. Yeah, so especially the overview of the BioSpec-nano. So it is indeed an informative one. So I am pretty sure that before the demonstration proper, so all of the participants here have gathered enough information to have knowledge on what is a BioSpec-nano and where it is used. Okay, so we are now on to our next speaker, who is Mr. Zen Hao Lee. So Zen Hao Lee is our application chemist from our regional office as well in Singapore. So Zen Hao obtained his bachelor's degree in chemistry in biological chemistry at Nanyang, and biological chemistry at Nanyang Technological University, or NTU. So he started working in Shimazu Asia Pacific in 2016 and has been handling various analytical instruments such as UVVs, FTIR, TOC, AAS, particle size analyzer, and RF. So for the past 5 years, he has delivered numerous spectroscopy training courses, provided application support for users from multiple industries, as well as developed application notes for Shimazu Asia Pacific. So without further ado, let's welcome Zenhao. Zenhao, please.
Hello. Yeah. So hi everyone. Thank you for having me in this webinar. So for this section, I'll go through on the software operation for this instrument and show you all how easy this instrument can be used for your analysis, especially in the life science field. So let me just share my screen. Uh, Hi, I am Zenhao, an application chemist from Shimazu Asia Pacific. Today, I'm going to give a short demonstration on the BioSpec-nano instrument and the software operation. First, let's look at the BioSpec-nano instrument. This is an instrument which enables the quantitation of simple and labile nucleic acid and protein from a drop of sample. The components in the BioSpec-nano are more or less the same as your traditional UV spectrophotometer. It uses a xenon flash lamp as a light source and contains a diffraction grating as a dispersive element. As for the detector, it uses a photodiode array or PDA. However, unlike your traditional UV spectrophotometer, the BioSpec-nano does not use a cell or cuvette. Instead, what we have here is the target where we could place our sample or blank solution for measurement. So, the task of washing and drying the cuvettes during and after the sample analysis is not necessary. The measurement would be conducted by sandwiching the solution between the upper window and the target, which I will demonstrate later. The volume required for measurement is relatively small, around 1 to 2 microliter. Of course, this depends on the path length used. This small volume is good since we are dealing with protein and nucleic acid samples, which usually are in small volumes. Another good feature for this instrument is that we have the automatic wiping system, consisting of the wiper cloth and the wiper arm. This system would wipe the liquid contact surface, which in this case is the upper window and the target, by a simple wiping, which I will show you later as well. Then we have the path length leveler to select the optical path length required. For this instrument, there are two path lengths to select, which are 0.2 mm and 0.7 mm. There is also an optional 5 mm path length, which enables the measurement at this optical path length using a 5 mm cuvette cell. So now what we are going to do is to turn on the instrument and let it initialize. And while it is initializing, we will look into the software. The software to control the instrument is the BioSpec-nano software. We'll click the icon on the desktop. From this window, we can select the method based on the item we want to measure, and there are 4 methods to choose from. There is the simple nucleic acid quantitation for DNA and RNA quantitation. Label nucleic acid quantitation, which is also a DNA and RNA quantitation, but with fluorescence dye labeling such as CY3 and Elexaflor. We also have protein quantitation, which determines protein concentration at 280 nanometer wavelength. And then we also have photometric method, which determines the optical density at specific wavelength chosen by the users. First, I'll go through the quantitation of uracil, which is a RNA nucleic acid. So in this window, we'll go to simple nucleic acid quantitation and select RNA. Here we'll click OK to finish the connection between the software and the instrument. Before I begin the analysis, I will first key in the sample name over here. Then I will proceed to my measurement, which consists of a blank measurement followed by my sample measurement. But before doing any of that, I'll need to clean the upper window and the target part of the instrument. Over here, I'm using a linen-free tissue with a bit of reagent alcohol for the cleaning. Next, I'm going to set the optical path length for the measurement. For this demo, I'm going to use 0.2 mm path length. After that, we can place the blank solution onto target using a pipette. Since the path length is 0.2 mm, the volume required is only 1 microliter. But if you are using a path length of 0.7 mm, the volume required would be 2 microliter. Going back to the software, we'll click the blank icon to start the measurement. Now let's look at the instrument operation over here. As you could see, the upper window would move downward towards the target. Then you'll see a blinking light which indicates that it is performing the blank measurement. Next, the wiper arm with the wiper cloth would be automatically wipe the upper window and target clean. Once the cleaning is done, the upper window will move back up to its original position. Now that we have done our blank measurement, we could proceed with the sample measurement. I'm going to place my sample solution on the target using the pipette. Then I would press the start button on the software. Similar to the blank measurement, the upper window would move downwards to the target and perform the measurement. Once the measurement is completed, the automated wiping system is enabled to clean the target and the upper window. On the software screen, we would be able to see the spectrum and the measurement result. Here it would display the nucleic acid concentration, the OD260 to 280 ratio, and also the OD260 to 230 ratio. Of course, this ratio would indicate the purity of the nucleic acid. If you want to see the full spectrum, we could click on the All Region icon. Typically for each measurement, it will normally measure the full wavelength range, which covers 220 to 800 nanometer. And since the BioSpec-nano uses a PDA detector, the full wavelength range measurement time will take around 3 seconds. Coming back to the automatic wiping performed by the BioSpec-nano, you might have some concern that it will cause carryover and affect the measurement results of your later samples. But just to demonstrate how the automatic wiping does not affect the measurement results, here I have performed a few measurements of the RNA samples and blank solution one after the other. As you could see from the OD value, they are quite consistent, giving good reproducibility. This shows that the automatic wiping has little carryover effect. This function also helps to save time, and you do not have the concern of scratching the lenses of the upper window when cleaning them manually after every single measurement. For the wiper cloth, it can be used up to about 100 times, and we could monitor the wiping count under the wiper status. But just to ensure good analysis result, we would recommend replacing it every day. Okay, coming back to the measurement results displayed on the screen, we could see one column known as judge. This is to indicate whether the OD ratio is out of the specific range. If you see the icon appearing under the judge column, this means that the OD ratio is out of the specified range. This range can be set under judgment setup, and the default range is from 1.6 to 2.4. Typically, the default range is mainly for pure DNA and RNA samples. So the reason why we are able to see this icon under the judge column is because the sample measure is universal, which usually has a OD260 to 280 ratio of more than 4. Next, we'll go through protein quantitation using BSA as an example. In the main window, we are going to select Protein Quantitation option. Under this tab, we would key in the molar extinction coefficient at 280 nanometer. If you do not know what is the extinction coefficient for your protein sample, we could go to the lambda 280 calculation button over here. Key in the tryptophan residue, tyrosine residue, and cysteine residue value, followed by clicking the calculate button. This will display the estimated coefficient value, and the calculation is based on the Adair-Hodge method. Next, we will select on to display the concentration value, and for this we will also need to key in the molecular weight for this protein. If your protein samples is labeled with fluorescent dye and you want to quantify that as well, you could select this option and select the dye used. Over here are the default dye information in the software. But if you do not see the dye that you are using, you could add and edit new dye information under the Manage label. However, for this demo, the protein is not labeled, so we will not be selecting this option. Once done, we will come to the measurement window. From here onwards, the operation flow is more or less the same as what we did for the nucleic acid quantitation earlier. Same thing first, I'm going to key in the sample name. Then I would clean the upper window and target part again with linen-free tissue and a bit of alcohol. For this measurement, I would use the same optical path length as the previous analysis. So I would leave it at the 0.2 mm position. After that, we can place the blank solution on the target using a pipette and start the measurement. Once the blank measurement is completed, we could proceed to measuring our BSA sample. Again, since I'm using the 0.2 mm path length, the volume required is only 1 microliter. Once the measurement has completed, the protein spectrum and the measurement result are displayed on the window. The concentration result displayed would be in terms of molarity and also microgram per microliter. Of course, for the microgram per microliter concentration result, it would vary depending on the key-in molecular weight. So let's say we want to view the report, we could select the display PDF icon. Here is the report with the measurement information, result, as well as the spectrum. But let's say if you have measured multiple samples and you would prefer the result to be in a table format. From the window, we can select the list icon first, then select the display PDF icon. Now we would have the result in a table format. We also have the option to export the data in CSV format. To do that, just click on the Save CSV and PDF icon. Select the option required, which in this case will select Result CSV with data. Key in the file name and it is done. Here is how the CSV file is when opened in Microsoft Excel. Let's say you want to obtain optical density values at specific wavelength. You could do that under the photometric mode. So now we'll select photometric option in the method window. Here we'll key in the number of wavelengths we want to measure, for example maybe 3 wavelengths. Then key in the required wavelength and click OK to proceed. Again, the operation is relatively straightforward. We just need to key in the file name, perform the blank measurement followed by the sample measurement. The sample that I'm going to use over here is the BSA protein. Here I'm going to perform the blank measurement. Now I'm placing the BSA sample and start the sample measurement. After the measurement, the OD values for each wavelength is displayed with the spectrum as shown as well. We could see from these few examples in this demonstration, the operation of the software is relatively simple and quick. This shows that the users can learn and operate the instrument in a relatively short amount of time. For this instrument, there is one optional accessory for it, which is the 5mm cuvette and the adapter for it as shown in the picture. The adapter allows the placement of the cuvette onto the target. The cuvette has a cap to prevent solution spillage. Here I'm going to show you how to use the 5mm cuvette on the instrument. First, we'll set the path length leveler to option. Then we'll place the adapter on the target. The cuvette is placed horizontally on top of the adapter and we could proceed with our normal measurement. Same as the 0.2 and 0.7 mm path length setting, the upper window would move down and touch the cuvette for measurement. The automatic wiper is disabled, so you will not see it move after the measurement is completed. For the maintenance of the instrument, there is not much for it except for the wiper cloth replacement once it is dirty. Here I will show you how the replacement is being done. From the software, we'll select the wiper exchange option. By doing so, it will move the wiper arm to the replacement position. Once in position, you could remove the used wiper cloth and replace it with a new one. Then, on the software, you could click Complete button, which will reset the wiping count number. If you prefer to maintain the wiping count number, we can just click the Close button instead. Either way, the wiper arm would return to the return position after that. That is all for this operation demonstration, and thank you for your attention.
All right, so thank you, Zenhao, for the demonstration. So it is indeed a worthy addition to our knowledge, especially that in the Philippines, actually traditionally, we only know the UV spectrophotometer, the normal UV spectrophotometer. Okay, so with that, we can proceed with the Q&A. So I've been receiving questions already, but don't worry, you can still type yours in the chat box. Or if you want to speak, to talk with our experts directly, please feel free, just type in your name in the chat box and we will give the floor to you. Okay, so let me read some few questions. Okay, so first question. What is the solvent or chemical that is used to clean the sample stage? So, Nicole or Zenhao, can you please answer? Yeah.
Yeah. So as I mentioned earlier, while I was cleaning the sample stage, I am using reagent alcohol. Typically, reagent alcohol is good enough for the cleaning part. Yeah.
Okay. Okay, so that sounds good. So next question. Sorry, I'll be reading it. Okay. Is it possible to use BioSpec-nano for normal UV visas analysis, wherein we will just set the wavelength and measure the absorbance?
Okay.
Go
Yeah.
ahead, Zhenghao. Go ahead.
Yeah. So in a way, you could use it, but just take note that the unit is measuring is actually optical density. It's not absorbance. So optical density, there's a conversion for it. So it is actually absorbance times a factor of 10 divided by the path length. So that is what optical density means. So it's not actually it's measuring absorbance, but it converts the absorbance value to the optical density. So it depends on your preference. If you're okay with using optical density, then yeah, you could use it for like the photometric mode that I mentioned earlier. And of course, another thing to take note is that the cuvette it is using is a 5 mm cuvette. In your traditional UV-based instrument, they'll be using 10 mm cuvette, but here it is using a 5 mm cuvette. Sorry if I spoken. So there is some difference over there. Yeah, just take note for that one if you want to use it to replace your traditional UV-based instrument. Yeah.
Yeah.
Uh,
Okay, so
Thank,
yeah. Okay, Nicole, yeah.
sorry, I just want to add on one point. I totally agree with what Zhenhao was sharing just now. Just one more thing we have to take into consideration is that if you look at the sample volume, right, it is only like 1 to 2 microliter, which is much less compared to any of the regular UV visible spectrophotometer. So unless your sample is really concentrated, otherwise do take a look, do take the volume into consideration as well. Yeah, thank you.
All right, so thank you, Nicole and Zenhao, for the answers. So next question, will there be any issue on stray light during measurement or any spectral interferences? This is a good question.
I believe there should not be much of a stray light issue because one, the path length used is relatively short. So as you could see just now, the window is actually sandwiching your sample with the stage. So I believe there should not be any stray light issue for this one.
All right. So next question, what are the consumables of BioSpec-nano?
I believe the consumable for this one is only the wiping cloth. Yeah, basically this instrument is quite straightforward. There's nothing too difficult to it. So like yeah, as you mentioned, consumable is mainly the wiper cloth lah. Yeah.
All right. Okay. So next question, what is the room requirement for the operation? Yeah, so I think he's asking about the room temperature as well as humidity. Is there a need for air conditioned unit?
I think just like any of the other analytical instruments, any of the analytical laboratory condition as a standard will do. So for example, the temperature, it should be below 65. It should be around, okay, in general, it's around 25 degrees. Of course, the instrument is not really affected by the variation of the temperature, but like try your best to maintain your analytical laboratory conditions. So even for the humidity, we don't recommend too humid. So especially in our region, our weather condition is very humid compared to some other Western countries. So a regular laboratory with regular maintained air count will do. So it's actually, yeah, any of the spectrophotometer, it doesn't really require very stringent laboratory conditions.
Yeah, correct. Yeah, so I agree. So
Yeah.
let's just follow the manufacturer's manual with regards to the condition in order to get our to have optimum performance of the instrument. Yeah, great. So that's a good point, Nicole. Okay, so next question. So can you set the wavelengths when performing simple nucleic acid analysis, or the OD is already set? Again, can you set the wavelengths when performing simple nucleic acid analysis, or the OD is already set?
For yeah, can you repeat for the second part, the OD part?
Yeah.
Yeah.
Or the OD is already set.
What can the one who posted the question explain on what do they mean by OD set?
Hi, hello, hello, Mr. Zenhao.
Yeah.
Uh, hi, I'm Franco from SPC. I would just like to clarify the question. The question is, is the wavelengths already set when you're performing simple nucleic acid analysis, or please disregard the second part about the OD.
Okay.
So if you're performing simple nucleic acid analysis, are the wavelengths for a particular nucleic acid already set, or is can it be defined by the user?
Okay, so for this software, yeah, the wavelength are already set at 260, 280, and 230 because this wavelength are mainly what users would be looking at, especially for judging purity. And yeah, this wavelength is also used for calculation of the concentration for based on the most common method.
Okay,
Did I
thank you,
answer your
sir.
question?
That's
Yeah.
that's
Okay.
yes, that's clear. Thank you.
Okay, so thank you, Franco, for raising the question, for clarifying, as well as Zenhao for your answer. So we are down to our last question, but don't worry, guys. If you have further questions, you can just send us an email. Okay, so for the last question, is generation of calibration curve necessary for this, both for nucleic acid and protein quantification? So again, is generation of calibration curve necessary for this, both for nucleic acid and protein quantitation?
Okay, so for this, you do not need to generate the curve. So as I mentioned just now earlier regarding the nucleic acid analysis, it is based on the wavelength used. So like for the nucleic acid, the concentration is based on the 260 to 80 part. So they'll use that, and there's actually an equation for it to convert that OD or absorbance value into the concentration value. Of course, for the protein quantitation, it involves a bit more. For example, like the molar extinction coefficient, and of course the molecular weight. So earlier when you saw, well, I was setting the protein, I need to like key in those factors or those values such that it will give you the concentration value. So in this way, for the protein part, the molecular weight and of course the molar extinction coefficient will affect the concentration value. Yep.
Okay.
Yes. Okay. Just
Sorry,
add
Nicole.
on
Yeah.
a little bit more. Yes. So calibration curve is a concept, I would say, which is required for any of the analytical instruments when you want to do a quantitative analysis, because the calibration curve is basically it's actually coming from the standard. Of course, for BioSpec-nano, so for example, for nucleic acid analysis, you don't have to repeat this step, because you can understand it this way, that it comes with the so-called the instrument setup. That's why you don't have to do. But in fact, calibration curve is a requirement for any of the quantitative analysis. Yeah. Thank you.
Yeah, okay, so that's actually a good point. Okay, so that's the end of the Q&A. So again, for further queries and clarifications or even requests for quotations, please don't hesitate to contact us by sending us an email. So thank you again to our colleagues from Shimazu Asia Pacific, Nicole and Zenhao, for being with us today. Yeah. So it is a great opportunity to having you guys in this webinar organized by Shimazu Philippines. Okay, let me just resume recording. Okay. So again, congratulations everyone. So for more Shimazu webinars, you can access those in Shimazu digital classrooms. The one you are seeing in your screen, you can just type in the Google Shimazu digital classroom and you will find it. Okay, so Shimazu digital classroom now allows you to learn at your own pace and convenience anytime, anywhere, because it is an innovative tool that is packed with Shimazu webinars, both live and recorded, on various analytical technologies, applications, solutions, and flow of information and compliance as well. And for more information regarding Shimazu products and services, so just visit our official LinkedIn and Facebook pages and feel free to send us a message if you have any inquiry. And just this year, we launched our YouTube channel, so you may subscribe please and watch a number of videos featuring Shimazu products and applications. And actually, some of our webinar recordings are already uploaded there and more updates are yet to come. So the recording of this webinar, I will be uploading this within this week. Okay. So this marks the end of our session for today. Thank you everyone for participating. Thank you to our colleagues again from Shimazu Asia Pacific, from SPC as well, and everyone else. And we look forward to your usual support in our succeeding webinars and other marketing activities. So that will be posted in our LinkedIn and Facebook pages. So thank you again and enjoy the rest of the day. So keep safe, everyone, please. Bye-bye.
Excellence in science. Shimazu.